All right, we'll get started. Okay, so first off, there's a question about the assignments. I talked to the marker today. She wanted a few more days, so she's hoping to get it back to you by Friday. As a reminder, your mark will come back to you through EAS, so you'll just get it automatically. Okay, before we start, is there any questions about anything, content from last week? Your next assignment I'll give to you next week. It will be doing what we do now. So doing this cognitive walkthrough, I'll ask you to do it on a different tool than the one that we do in class, but you'll do the same process. So being here is useful for getting a head start on assignment 2. Okay, so seeing no questions. So just as a reminder, we're talking about usability. So how do you tell whether a system, and particularly a security system, is actually usable? And if it's not usable, then you could have problems because users might not use it. They might try to circumvent it. They might not use it correctly. They might make dangerous errors. So there's different things that could go wrong. And in the worst case, if you had an unusable system, then you might as well just not have a system at all, right? It's no better than not having a system at all. So usability could kill your entire experience for your users, which could actually end up not achieving like what you want from a security perspective. So we talked about 3 methods to evaluate usability. So one is you can pull users into a lab. You can get them to experiment with whatever you're testing the usability of. So that's called a user study. If you had a polished solution and you wanted to test it at scale, if you say you work in a company, you could roll it out to half of your users or something like that, and you could test it. So that would be a field study. And before you do either a user study or a field study, what you should do is think through the usability for yourself. And so you might use expert review. So expert review is just one person, or maybe you have a team of a few people. They look at the usability of the software. They usually know how the software is supposed to work, so they're not novices. And they also know a bit about usability and what the principles are for usability. Okay, so the cognitive walkthrough is where you define a set of tasks that you want to do, and you just go through the process of basically doing those tasks. And then at every step away, you ask yourself some questions about usability. Okay, so we'll do a concrete example. So we'll use Tor. Tor is an anonymous browser for your for the internet. So basically, you can visit websites and it will hide your IP address. I looked at Tor personally when I was a grad student. So when I was your age, I had a course project and I decided to do a usability study of Tor. And so that was 15 years ago. So I'll give you what I did 15 years ago, and then we'll redo it in class. And a lot has changed, as you can imagine, in terms of the software itself. But before we do, let me tell you a bit about Tor and how it works. So remember, we want to be dual experts. So we want to know a bit about usability, and we want to know a bit about what we're studying. So I'll try and paint a picture of what it does, which will be useful when we look at the usability of it. So first off, it's software, if that wasn't clear. Okay, so it's something we're going to download, we're going to install it. I don't have it installed on this computer, so we'll do everything from scratch. And basically what it's going to do is it's going to provide you some level of anonymity when browsing the web. And what anonymity in this context means is it's going to hide your IP address. Okay, does anyone else know a way of hiding your IP address? Okay, so the most common is to use like a VPN. So let's compare and contrast Tor to VPN just so you can see what the differences are. It uses the same principle, it has a little bit stronger anonymity. So let's say we have a user, and we have our VPN or proxy server, and then we have the actual resource, the actual website, Google, Facebook, whatever it is that we want to access. Okay, so in a VPN, it's really simple. It just forwards your traffic. Okay, so the user would make a request to, say, Facebook, but what they would do is they would configure their browser so that it would make the request to the VPN instead, or they would configure their operating system. We'll talk about it, but somehow the user's client knows to go to the VPN instead, so it would send a request, and then the VPN will basically just forward the request. Then the server will give a response, and the VPN will forward the response to the user. Okay. Now, why does this provide anonymity? So the user has an IP address, and the IP address is tied to the request. Okay, so in the envelope that contains the request, the IP address is written on the outside of it. Why? It has to be there because when the response comes back, you have to know where to send it. Okay, so you have to say, this is where I want the response to come back. Could you write someone else's IP address on it? You could, so that's called IP spoofing. In that case, would the response go back to them instead of you? And the answer to that is sort of complicated. What we're talking about here runs over what's called TCP. And in TCP, you first have to do a full round of communication before you start sending requests. And so if you spoof an IP address, you won't be able to complete that round of communication. It will try and complete it with the other person, and the other person doesn't know anything about, creating this TCP connection, and so they'll just ignore it and drop it, so it will never get formed. If you use UDP, UDP is where you don't have a connection. You send a request and it sends a response. There's no setup. This is used more for like streaming video, that kind of thing. Then you can spoof it. We did talk about spoofing like way back in the very first lecture when we talked about amplification attacks for denial of service. So you might remember that. But anyways, everything we're talking about here is like HTML, which is running on HTTP, which is running on TCP. Okay, so you can't spoof IP addresses. Okay, so you put your IP address on the request, and this is the IP address of the user. And so what happens is when the VPN forwards your request, it puts its own IP address on it instead of yours. Okay, so the idea is that Facebook or whoever is here, they only see the IP address of the VPN. Okay, so they have no idea who the user is. The VPN, on the other hand, they know who the user is, and they also know where the traffic's going. They know that it's ultimately going to Facebook. Okay, so the VPN is capable of, whether it does this or not, it's capable of keeping basically a log that says, okay, this is the user IP, and they were going to Facebook. And then for every site that you go to, they could fill this log out. Okay, and then maybe law enforcement is interested in that at some point, so they could go to one party, the VPN, and they could get this log, and then they would be able to trace users, so it's not anonymous anymore. It could also be the case that the VPN is law enforcement itself, right? You don't know, sometimes you just choose a VPN randomly online, you don't really know who's running it. It doesn't have to be law enforcement, it could be people that are selling that information, so they're selling it to a third party who wants to know what IP addresses are visiting different websites, things like that. So people generally use VPN when they want to hide their IP address, or the other most common case probably is that you want to make your IP look like it's coming from a location that's different than your current location. So in that case, you don't really care about logging stuff. So if I want to watch some I don't know, soccer game and I have to be in the UK to watch it online, then I might geo-hop, as it's called. I might use a VPN to make it look like I'm coming from the UK so I can access BBC or whatever. So anyway, so that's the story there. Now, what about Tor? So what Tor is it's kind of like a network of VPNs. So you have a whole set of VPNs, or they don't use the language VPN, they call them relays. And what the user does is they configure their client to choose whatever, let's say three server nodes at random, okay? So they might decide, okay, I'm going to choose this one, I'm going to choose this one, and I'm going to choose this one. And then their browser operating system, we'll talk about that in more detail, but somehow their client is configured so that they send their information through 3 of these relays in a certain order. And then it pops out at Facebook or whoever. Okay, and then there's a way for the responses to come back. It's kind of complicated, but anyways, you can believe that there's some way that the information, and it comes back the exact same way it went. So here's the request. Here's the response. Now what it does in addition is it provides encryption. And so it, first off, let's just go back to this example. With a VPN, you could have encryption here if you wanted. So you could have encryption between you and the VPN. But you're not going to have encryption, at least not necessarily between you and Facebook. Now, or between the VPN and Facebook. So this would be like some sort of custom. Now, what if you did HTTPS? Okay, so let's say you're accessing Facebook over HTTPS. Do you have a secure tunnel all the way to Facebook, or does it go to the VPN and then the VPN forms a secure tunnel to Facebook? Okay, say again, but louder. Okay, so it could be like a man in the middle where you have pairwise encrypted tunnels. But HTTPS is actually end-to-end encryption. So what end-to-end encryption means is it gives you encryption all the way to Facebook. So the VPN, they see HTTPS traffic. So they see your request. They don't know what it is, right? It's encrypted. They know where it's coming from, and they know where it's going. Remember, we said that you can't hide that using HTTPS, otherwise packets can't find where they're supposed to go. But the content of the packet, you don't need, if you're just forwarding traffic, you don't need to know the content. Okay, so if you were to use HTTPS, you could still have a secure connection all the way to the end. So this would be like... try and draw this better. So if you had HTTPS, you would still, it would tunnel right through the VPN. Okay, so the VPN would see the outer layer of the packet, but it wouldn't be able to see the inside content. Now, we saw all those fingerprinting attacks and things like that, right? So the VPN still sees a lot of information. They see the size of packets. They know you're going to Facebook, even if they don't know what you're doing on Facebook. They know all the images and mixed content that gets weaved together. So, yeah. But anyways, and then the pink here would represent some sort of custom VPN encryption. And so VPN does, usually, generally, like a VPN server will have encryption between you and it. Okay, that's why it's called, that's the P. So VPN stands for virtual private network. And so there is a concept of a proxy A proxy server is exactly the same as VPN, but it doesn't have that pink encryption. It just forwards everything, but you talk to it with plain text. But once you have encryption between you and the proxy, then we generally call it VPN as opposed to a proxy, but it's the same idea. Okay, so what Tor is going to do is it's going to do the same thing. What it's going to do is it's going to give you encryption, and I'm going to try and draw this really nicely if I can. So if you have HTTPS, then your encryption would go all the way through Tor, all the way through all the routers or relays, and it would end up at the server. In addition, Tor will give you encryption between you and every node that's between you and it. And the way it does it is it sort of tunnels encryption tunnels inside of encryption tunnels. So it will give you a big pipe that will go all the way to the last node. And that encrypted tunnel will be inside another encrypted tunnel that goes between you and the second node. So this gets kind of messy, but if you just watch me draw it, you'll at least get hopefully the idea. And then all of that is inside a big encrypted tunnel that goes between you and the first node and back. Okay. So this is where so Tor it doesn't stand for anything, but originally it was said to stand for the onion router. And the idea of an onion is that you have encryption inside encryption inside encryption, and everyone is sort of peeling a layer off. So when your traffic between you and the first node is actually encrypted 4 times. Once for between you and the first node, once for you and the second node, once for you and the third node, and then if you're using HTTPS between you and the final website. The first node strips off 1 layer of encryption, so now your traffic's only encrypted 3 times. The second node strips off a layer of encryption, so now it's encrypted twice, and then the final node, the exit node, it will strip off another layer of encryption, and so now it's only encrypted once with HTTPS all the way to the website. Okay, all of this doesn't really matter. I just thought I would explain it for fun. But the main property here is, remember, if we have a VPN can keep a log, username, Facebook. Every relay here can keep a log, but all they know is, let's take this relay here. If they want to keep a log, all they know is I got some traffic from, I'm going to call this R1 for relay 1, relay 2, and relay 3. So all their log is going to say is, hey, I was getting some traffic from R1 and I was sending it to R3, right? I have no clue. I don't know anything before R1, okay? So I don't know where R1 got it from. I don't know who Alice is. I have no idea where it's going. I sent it to R3. I don't know where it went after that. Maybe it went to another relay in Tor. Maybe it went on to a website. I have no idea. All I know is I saw traffic between R1 and R3. Similarly, R3, they kind of know more information because they know that ultimately this traffic went to Facebook, but they don't know where it came from. They only know, oh, it came from R2. Okay? And then similarly, R1, they know who the user is. But they only know that they were sending it to R2. Okay? And then Facebook, what Facebook sees is they see a request come out and it has the exit nodes R3's IP address. Whoops. Okay, so let's say you want to know who was it that accessed Facebook at a certain time, right? What you would have to do is, or this is in the ideal case, what you would have to do is you would have to basically go find R3, get the log from R3, then find R2, get the log from them, then find R1, get the log from them. And then what Tor does deliberately is it puts its relays in different countries around the world. Okay, so you're not going to bounce through 3 servers in the US. You're going to go to the US, and then you're going to go to Europe, and then maybe to Asia, whatever, and then it ends up in the final traffic, wherever it ends up. Okay, so they deliberately do that so that it's really hard to break the anonymity of the system. And you don't have to use 3 nodes. You can use 5, you can use 7, you can use a VPN and then use Tor, whatever you want. It's a very flexible kind of protocol. Okay, now one thing I'll just tell a story because it's kind of funny. There was so this actually happened at Harvard University. So someone wanted to get out of writing an exam, and so they decided that they were going to report a bomb threat, or they were going to report a bomb, and it wasn't real. So they just made it up. It was a student, and so they said, "Oh, I have a good idea. Instead of calling up, it might be traceable. I'm going to send it through Tor. Okay, I'm going to email it to the administration, and I'll email it through Tor, and I'll use a fake Gmail account or whatever the case may be." So they did it. So they emailed it to Tor, or sorry, they emailed it through Tor to the university. So what does the university see in this case?
The last IP.
They see the last IP address. Okay, so they have no idea who the original person was. Okay, so there's no way they could trace that email, right? Okay, so let's say they can't. So the logs are, I don't know, they're in Europe somewhere, and it's a crime what the student did, but it's not that serious of a crime. So they're not going to get like the logs extradited from like another country or something like that. Anything else? Okay, well, first off, what they could do is, and this is probably their thought process, is, oh, we have the IP address of the person who emailed it. And then they realize, oh no, this is a Tor IP address. Okay, so the list of all the nodes on Tor have to be public because otherwise you can't find. Actually, that's not slightly untrue. There are some hidden Tor nodes that are used in countries that would deny lists like all Tor relays. But anyways, forget about that. So basically, as long as you're not in like a country that's like filtering the internet, your list of nodes are all public. So Harvard knows this came from Tor, right? Just doesn't know, right? So who could have it ultimately come from? Could it come from anyone, anywhere in the world? Sort of, but it would have had to come from someone who was using Tor at that time.
Yes.
Okay? So anonymity always, the concept of anonymity, or the way to think about it, is you have a set. So if you're anonymous, you're always anonymous within a set, right? So someone in this room does something, well, we have a set of people. It's not someone that's outside the room, it was someone that was inside this room. We don't know who it is, but we do have a set of people that it could be. The anonymity set of Tor is all the Tor users that were using Tor at that time. Okay? So that's the first important distinction. So it's not truly anonymous, right? But it gives you this cover set. Okay? So then what Harvard did is they said, I wonder if anyone was using Tor from our Wi-Fi network at the time that this email got sent, right? How would they know that? Okay, so remember the R1 here, right? They know the true user IP, and R1 itself is also a Tor node, okay? So if they control the Wi-Fi, then they can look at, oh, what's all the traffic that's going from any user to any R1 that's on Tor. Okay? So they could see every user that was on Tor at that time, and they know that the email came out of Tor. So when they looked, turns out Tor's not that popular at Harvard, and there was only one user who was on the network at that time. And so they couldn't prove it, right? Because maybe that user was someone different, right? That just happened to be using Tor. And the real person, they were using Tor, but not from Harvard's network. They were at the Starbucks across the street or something like that. But anyways, they brought them in, they questioned them, and then the student admitted to doing it. And so they caught them. So anyway, so that shows you that there's subtleties. You have to have the right mental model, right, of this. It's easy to make mistakes using the software because you just think, oh, it's bulletproof, right? There's these 3 routers. You have to compromise all 3 of them. If you can't do that, then no one can ever tell anything, right? But when you understand the system and the details, then you start to realize, oh, there are like certain things that you could tell. Just like HTTPS, right? Like it looks bulletproof, but then turns out there's a lot you can tell just by looking at the outside of the packet. So Tor's sort of like that as well. Yeah. Yes, please. Mm-hmm. Good question.
Like torrent, torrent, each person has
Yeah.
my IP address, I joined them, or no?
Yeah, okay, so the list of Tor nodes are volunteers. So they're people who just volunteer, they throw a server up, and and then they get added to the list. So you don't actually know who they are. You can sort of be reasonably sure of where they are, but you don't really know. You're just choosing from a random list. Could law enforcement run Tor nodes? Almost certainly they do, right?
If these students send the email outside the university, they don't.
Yeah, that's right, exactly. So had that Harvard example, if they had just gone across the street to Starbucks and used the Starbucks Wi-Fi, then they would have got away with it.
And
Yeah.
another question.
The other thing, can I just circle back to who the nodes are? So they are random, they're volunteers, but at the same time, Tor has a face. Like there's people that run Tor, and the people who volunteer on the network often, like they're not hiding, right? Like for example, the university that I was at, they have a Tor server, right? And so they make it known. And the person who runs Tor, like the person, the main person that runs the project, he personally knows the person at Waterloo that runs the Tor node kind of thing. And so it's not like just a complete random set of nodes. A lot of them are sort of like people know the people that run them and things like that. But yeah.
Another question, if I join to Tor and I use the Tor, I will be one of the node or not?
No. So, well, you can choose. So you can choose to volunteer to be a node. But by default, when you use Tor, you're just a user. So you're sending your traffic into Tor. And normally you wouldn't run Tor as a node from a normal computer. You would have to set up like a network or like big infrastructure and things like that. So in the early days of Tor, I think it was perceived more as a peer-to-peer thing where like it was easy, like you could just click a button and then become a Tor node. But now because bandwidth is so big and you need infrastructure and things like that, I'm sure that the software to be a server is completely different than the software to be a client.
Another question, when we disconnected Tor, I used the same like you 15 years ago.
Mhm.
Because I did the new one. I know the Tor, and we can check, for example, BBC and
Yeah.
on the website. And when we disconnect web browser, we open again, we randomly choose the Tor randomly choose one node. Yeah.
Yeah. So the way Tor works, I don't know the exact configuration, but I believe it's on a timer. And so I think every 10 minutes it tears down the circuit and then changes it. Yeah.
And the last time I used for Echo Shoes, Echo has a promotion
Yeah.
on the website. When I click in my browser, it knows I am, and they don't give me the promotion. Then I use the Tor, another IP address, which 10 seconds, and I can take the
Right.
my chance.
So that works. But then once any Tor user uses it enough, then eventually all Tor nodes will have visited that website.
When I
Kind of
click
thing,
open
but-
again, I have another IP address.
Yeah, exactly. So you can reset your circuit, you'll get a new exit node, and then the website's going to see a new IP address. And so you could sit there and do it until you run out of exit nodes.
And another question about VPNs. I see some VPNs, for example, I want download the torrent file.
Mm-hmm.
Some VPNs doesn't support the torrent, but some of them support it.
Yeah.
What is different between them?
Okay, so BitTorrent runs, first off, it generally runs on a specific port, so it's easy to identify. But even if you set up a custom port, then there's going to be header files and things like that, and then you can look at it. And then you can wrap it in encryption, and then maybe you can get it so that like you can thwart their like packet sniffing, basically. So if they do deep packet analysis, they can probably figure it out. But if they're just doing shallow, like kind of surface level, you could encrypt it and go to a non-standard port, and then you could run BitTorrent. And then the question is, why do they do it? It's just because it's high bandwidth.
Some of them support, some of them doesn't support.
Yeah. So it's a bandwidth question. So it costs them money. Like the more bandwidth you consume, the more money they're paying, and so it depends on whether they want to support it or not. Yeah. So Tor is notoriously slow. You'll see it. But it's more slow in terms of latency. So like you ask for something, it takes a long time to get a request. But if you're downloading a large file, it's going to start, like it's going to take a long time to start. But once it starts streaming, it's going to come to you fast. Like it won't slow down your download speed. It doesn't affect the bandwidth. It just affects the latency itself. But yeah, I thought I'd throw that out too.
And the last
Yeah.
question, when, for example, I use VPN, when they hack the VPN server,
Yeah.
everything.
Yeah.
Who connected to this VPN?
So it depends on the VPN themselves. So the VPN may or may not keep those logs. So some of them are like, yeah, we could keep the logs, but we don't. Like we promise that we don't keep the logs.
But we don't know.
But you don't know.
Maybe they do.
Exactly. At least with Tor, you know that even in the worst case, they do keep the logs, you still have to compromise 3 of them. Yeah.
Could you explain that again about this tables, R1 and R3?
Yeah. So R1, R2, R3 are the 3 Tor nodes that you route through.
Yeah.
And so basically, you don't have to look at the tables, just look at the picture. R2 only knows it got something from R1 and it's giving it to R3.
Yeah.
And similarly, R3 knows it got something from R2 and it's sending it to Facebook. Yeah, so everyone just knows their nearest neighbor. They don't know the full path.
Here R1 and R3, but I couldn't find R1 and R3.
Yeah, so R1 is here and R3 is here.
But, yes.
Yeah?
Yeah.
Okay.
Thank you very much.
Okay, no problem. And then, so go back to your example. So let's say Iran decided to ban all Tor nodes, which it probably has, right? Then how do you use Tor in a country like that? And so the answer is that you can't. Basically, there's no technical solution to it. But what the Tor project does is they offer these like kind of bridge nodes that are kind of outside of the Tor network, but they can feed traffic into the Tor network. And the way you get knowledge of a bridge node is just like by word of mouth. So they might work with like certain organizations within a country to share some of these bridge node IP addresses. And so yeah, so that they do it in China, for example, and I assume in Iran and other countries like that have restrictive internet. Okay, any other questions about Tor, how it works? Okay, so let's try it out. So the first thing we need to do if we're doing a cognitive walkthrough is we need to define a set of core tasks. So we're not going to evaluate every single thing. We're not going to go through the user interface and look at every menu and everything. We're just going to say most users, they want to do a certain set of things. So let's just walk through that process and evaluate it in terms of those tasks. So the core tasks that I did when I did the project, we'll just borrow them. They're like the 4 most basic things that you could do. So successfully install Tor and the components that you need. So Tor used to work. It worked a lot different 15 years ago. It required you to install 3 or 4 things. Now it's, as you'll see, you just get one bundle and it does everything for you, which is nice. Then you have to configure, basically make sure that Tor is working. And so it used to be the case that you would use your normal browser. So you use Safari, Chrome, whatever you use, you'd have Tor running, and then you'd have to get the two to talk to each other. And that was like a bit of a nightmare. So now what Tor does is they actually just give you a browser. So you download a browser, and the browser is Tor. It's a Firefox variant, and it just works with it. So it makes this a lot simpler. Then you want to make sure, like, okay, how do I know it's working? Is it working or not? How do I know it? And then you want to be able to disable it, know that it's disabled, and return to your normal like direct connection. Okay. Then the second thing we need for a cognitive walkthrough before we actually start doing it is we need a set of guidelines or heuristics. By the way, this paper, if you want it, it's on the course website. So it's called Tor Study here, and so I just what I'm putting in there is just copy and pasted out of it. So, okay, so the guidelines that we'll use are the following. Okay, so I'll go through them. We'll refer back to them as we do the actual thing, and I'll write down. I'm just going to write down some notes. We'll mainly just talk through it, but I'll scribble down a few things, maybe take some screenshots. But I'll just refer to G1 through G8. These sets of guidelines work actually well for software. So this isn't really. These weren't guidelines that were written with Tor in mind. They weren't even written with security in mind per se. They just generally work. Actually, I should say they were written with security in mind, but not all the guidelines concern security, and so they are a pretty general set of tests. Okay, so the first one is that users need to know, like, they want to do a core task, so they want to get Tor to run. Okay, they need to know what they have to do, right? How do I get Tor to run? Like, I have to go to the website, I have to download the software, and then I guess I'll just figure it out as I install it and try and figure it out. Okay. So they should be able to determine how to perform these steps. And once they've done one of the steps along the way, then they should know that, okay, I'm done. Okay. It was successful. I can move on to another kind of core task. Now, as they navigate through the process, they shouldn't make errors. Okay, and this is where you're going to put your hat on as, I know a bit about Tor, like the Harvard bomber or whatever, right? That's an error. They made an error, right? And so you need to foresee that error is possible, and then you have to see if the interface would make it easy for some user to commit an error like that, okay? And you can sort of split them into like what I call G4 and G5. So G4 is just sort of like not critical error, or it's an error that you can recover from. Right, so you can make the error, you can figure it wrong, but you can go back and reconfigure it if you figure out. And then G5 is like, you made a mistake, it's too late. Like, you sent that email, it's gone, right? And even if you figure out after, oh, like, oops, I should have not sent it from the Wi-Fi network, it's too late. That email's gone, the IP address is on it, your IP address connected to Tor is there, it's over, kind of thing. So that's like a dangerous error. Is basically an error that you can't recover from. You should be comfortable with the terminology. So sometimes we say jargon. So jargon is like, words, like technical words that a normal user wouldn't understand. You should be comfortable with the interface. So if there's anything about the interface that's kind of weird, that might make users uncomfortable, you could note that or flag it. And then you should be aware of the status at all times. Okay, so you should know, like, am I done? Is it working? Is it anonymizing? Is it not anonymizing? Like, what's the status of what's going on? Okay, so basically what you'll do is you'll go through the core task. So you'll put yourself in the shoes of a user that's going to install Tor and the components in question. And then you're just going to flag issues. So if you see an issue with jargon, then you would write down, oh, like, there's this issue and it violates G6, which is the jargon one. Okay. And as you go through the process, you can flag both good things and bad things. So generally, the reason you're doing it is you want to flag the bad things, right? That's the whole purpose. But sometimes if you want, you see something you really like and you're like, oh, they did a really good job of this, then you could also make a note of good things as well. So yeah. Okay, so let's try and do this. All right, so core task 1 is basically let's get it installed. Okay, so how do I install Tor? Okay, I'm going to take the first thing I heard, which is Google it. All right, now most people wouldn't even necessarily Google Tor. They might not even know what Tor is, okay? So they might Google, like, I don't know. What would you Google if you wanted something like Tor? Is Anonymous even like a...
Tor, Wikipedia, the first I understand what is the Tor.
Sure, but would you even use the term anonymity, or is that too technical? Yeah, so you could do secure browsing. Let's just see for fun. So we get lots of stuff. Google safe browsing, things about tracking. I don't see anything about Tor. If you knew about Anonymous, you could say. So I'm sure if we read some of these listicles, they would list Tor. So private browsing probably wouldn't bring it up. We can try it, but recall private browsing actually is something different, right? So private browsing is like when you go like this. So now I have a private browser window. What does that do? Anyways, I'm curious. Does anyone know?
Doesn't keep the cache.
Okay, so it doesn't keep the cache, but that's something that's on your computer anyway, so no one knows what's in your cache or not.
The history isn't saved. It's the same.
So it doesn't hide your history. Yeah, or sorry, it doesn't save your history. So when you close the browser window, then your history goes away. So if your threat model is like someone else sitting down at your computer and trying to figure out what you were doing on it, that's where this could help. There's another thing it does that's probably more important. It resets your cookies. Okay, so right now I have an empty cookie jar. So even if I go to websites that I'm like, keep me logged in, when I do it from here, I'm going to be completely logged out. Okay, and as I use it, I will build up new cookies. Okay, so it's not like cookies are disabled, it's just they're reset. So it's like I bought a brand new computer, I turned it on for the first time, and then as I use it, I'll accumulate cookies, but then once I close it, then all the cookies are gone. And if I open another one, then I would get it as well. All right, so anyways, if we search for anonymous browsing, we do find Tor eventually. So it's here. Okay, so this is the website. So they have it pretty prominent here, download Tor Browser. I don't know if it could be any more obvious. It does tell you a bit about the kinds of things that it does. So it blocks trackers. This actually, to be technical, doesn't have anything to do with Tor. So Tor doesn't do anything about trackers specifically, but usually when you get the Tor browser bundle, it comes bundled with other privacy tools as well. So it's not the whole proxy network thing that's helping with this. It's the other stuff that they have in the Tor browser. This is mainly what Tor is going to do. This is actually interesting. So just for your own curiosity, where's our picture? So let's say that you have two users, Alice and Bob, and they're both using Tor, right? Could you tell them apart? So you can't tell them apart based on their IP address. Is there any other way that you could tell them apart? So you saw the word fingerprinting. What does that mean? That's the right answer.
Basically, see what websites they're visiting what like.
Okay.
Look like?
So let me clarify. By they, I mean, I should have said it a bit more explicit. Could Facebook tell the difference between Alice and Bob? So let's say Alice and Bob are both using Tor, and you are Facebook in this case. You're not Tor trying to figure out who it is. You're Facebook. Can Facebook figure out whether it's Alice or Bob?
Yes, sure.
Okay, so the answer is yes, fingerprinting, but anyone have an idea of what that means?
Because Facebook is the one that issue cookies. So of course it knows that this cookie belongs to Bob and this cookie belongs to Alice.
Okay, so let's say that the person's not logged in at all, and Tor like does a private browser window, something like that, or when you start using Tor, then it clears your cookies.
Okay.
I can formulate the question maybe a little bit easier, but it won't help you with the answer. Let's say that Alice goes to Tor today. Okay. Tomorrow, Alice goes to Facebook over Tor yesterday. Okay. Today, Alice and Bob are both on, or somebody. Let's just say someone shows up at Facebook. Is that Alice from yesterday, or is it a brand new person, Bob? Right. That's basically what Facebook wants to answer. So if it had a cookie and it put it in Alice's computer and she maintained that session, then it would say, oh, that's the same person from yesterday. Maybe I don't know it's Alice, I don't know her name, but I know that it's the same person. But let's assume the cookies are cleared. Is there any other way I could tell? So what can Facebook actually do? Right? They can look at the packets. The packets have IP addresses. There's not really anything else that's identifiable on them. Is there anything else Facebook can do? So they can control the website that comes down, right? And the website that comes down, it could have things like JavaScript in it. Okay, what can JavaScript do? Could JavaScript ask for the IP address? So it turns out the answer is yes. Okay, so JavaScript can just say what's the IP address, and then the browser will say, oh, my IP address is blah blah blah, and then JavaScript can phone that home to Facebook. Okay, so scripting's bad. Another thing you might do is you might say, well, I'm Facebook, I want my website to look pretty, so I want to know, like, I have a custom font. Do they have it installed? What's the dimensions of their screen, right? Because do I give them the mobile version or do I give them the desktop version? Okay, so there's all these things that you're permitted to ask as a website, and it turns out that everyone has kind of a unique configuration. Right? So even if you have the exact same, we both have MacBook Airs, depending on what websites I've browsed in the past, I'll have a different set of fonts and other like little configurations that are going to look a little bit different than yours. Okay. So anyway, so you can fingerprint all of that, and then you can actually tell users apart. So another thing that Tor does is because they give you a browser, they make sure that every copy of the Tor browser has the exact same fonts installed, the exact same screen dimensions and things like that. And it won't, as you visit websites, it's not going to change that configuration. It's always going to respond with the same thing. So anyway, so that's another thing that Tor does. Whatever. So and then the multi-layered encryption is what I sort of tried to draw out. It was kind of hard. And then anyways, browse freely. Okay, so let's install it. So we're going to download Tor Browser. I'm going to download it for Mac OS. And now I remember that I should actually do this before class, because now I have to kill a minute talking about something. While we wait out, let me just make a quick list of some of the random things that we talked about, just so that if you're only looking at the notes, you'll remember that there's audio that covers them. So we talked about anonymity sets. I don't know why this pen's not working. That was like the Harvard bomb. And we talked about fingerprinting. Okay, so we're done. I'm going to open it up. Okay, so this is a pretty standard kind of Apple installation. If you use Apple, you'll sort of recognize what you see. All right, so basically all I did is I Googled it. There was a download link that was pretty prominent. And then the installer was just kind of standard. Okay, so do I think a normal user would be able to follow all of these steps? Probably. I don't really foresee a problem. So G1, G2, G3 are pretty much okay. Up to this point anyways. Okay, how do I actually install this now?
Drag.
All right, so you drag it. So that's kind of weird, right? But anyways, if you use Apple, you're used to that. Sometimes they make it more obvious, like they have like a picture where they're like, drag this here kind of thing. Okay, so success, it's installed, so let's run it. Okay, so first thing I do is I get a little error. Tor Browser is an app downloaded from the internet. Are you sure you want to run it? Safari downloaded this file today from Tor project. Apple checked it for malicious software and none was detected. So this is the kind of thing that, this is actually Apple's doing. Is there anything that Tor could do to avoid this popping up? Anyone know?
Use a different download provider.
Not sort of, yeah. So what they could do is they could register with Apple and have a software certificate and sign it with it. And then if they distribute it through the App Store or something like that, then you could suppress this warning. Can't seem to move these pictures once I drop them in. But anyways, so this could be suppressed. Apologize for the writing. It's like 90% of the time this works, but sometimes it just lags. Suppress by, registering. Okay, so let's open this. Okay, so this is new. I haven't seen this sentence from 2 years ago, but it's actually really nice. I like what I'm seeing. Okay, so the very first screen basically says, okay, so Tor Browser routes your traffic over the Tor network run by thousands of volunteers around the world. Okay, is that understandable? Yeah? Okay, so it's good on jargon, which is G6. Okay, it's a nice, simple way of explaining it. It gets to the main point. And then remember that the core task, one core task is you should always know the next step that you want to do. And once you're done it, you should know that it worked or whatever. Okay. So this is very explicit. Right now, I assume reading this, I am not on Tor. Right. It's asking me to connect to the network. So I assume that right now, before I interface with this dialog, that I'm not actually connected to Tor. Reasonable? Okay, so I'm aware of the status. So I know that my core task isn't completed. Okay, so it's great on G8. So this is aware of status, and the status is not connected. Now I want to get connected. Okay. So that's, we're already installed it, so we're on to, I mean, core tasks 1 and 2 are sort of done. So this is concerning core task 3 now, which is get yourself connected, make sure, and then confirm that your stuff is being anonymized. Okay, is it clear what I do to actually connect? Do I know what that next step is? So it's pretty obvious, right? I click connect, and then now I think I'm going to be connected. So I at least know what the next step is that I should do. Okay? So the next step is clear. So that's G2. All right, so I'm just going to connect. And actually, let me go back. Oh yeah, okay. So another thing to notice is that they don't give you an option to, you can't be like cancel or something like that. Like I don't want to connect, right? So like imagine they had a cancel, then what? It would just be a browser, but you wouldn't be on Tor, right? So like basically you can only connect, or you can change your network settings, right? And I can't go up here, I can't start, well, let's just try it and see what happens. So if I try to navigate without connecting to the network, then it's going to stop me from doing it as well. Okay. So it also avoids, sort of click-throughs where people are just clicking on stuff, trying to, not reading. We're just going to click on it. We click the purple button, it does what we want it. If we click the gray button, we'll see. I'll click it. But if we just start using the browser and just ignore it, then it's not going to work as well. Okay. So there's no click-through. There's no way to commit a dangerous error. So it's good in terms of G4, G5. I don't know whether they're critical layers or not, but it's good in terms of G4, G5. Now, just for fun, let's just see what happens here. So if we go here, these are all the different settings. And so it's going to set, it's going to come up with a set of defaults. So we mentioned in class, another principle of usability is your defaults are important. So let's just take a look for fun. I haven't looked at it for a bit. So there's stuff about whether you want it to be a default browser. This is not really privacy or security related. .onion sites we won't explain. Cookies. So you'll notice here they say it's in permanent private browsing mode. Cookies and site data will always be cleared when the Tor browser is closed. Okay, so that's trying to give you some information about the status of the application at all times. Okay, so that's concerning with G8. And knowing how to sometimes you set something up and you know that it's working, but then you're not sure when it stops working. Okay, that's another important thing. So like, I got my encryption, it's going, but like, is it going to go for the rest of the day? Is it going to go till tomorrow? Like, when does it stop, right? What's the action that I would take to stop it? That's also important. So here it's very clear that your cookies are going to accumulate, but when you close the browser window, that's the event that stops that accumulation of cookies. Okay, and then Tor settings, so you can always connect automatically. This bridge things is what I mentioned. If you're in a place where the Tor network as a whole is blocked, then you have the option of putting a bridge in. And if you use a proxy, there's advanced configurations and this type of thing as well. So all this stuff is turned off. It used to be the case in previous years that it would actually walk you through a wizard that would ask you all these questions about this stuff. So it would be like, okay, are you on a proxy or not? And then we used to criticize it for using jargon, and it's not really clear what it's asking and things like that. But now that I've used it a few years later, they built it into the default settings. And like, most people aren't going to use a bridge. Most people aren't going to use a proxy. And so it makes sense to just have the default, like what works for 99% of people. Okay. Yeah, so next year I might have to choose a different software to look at because I'm running out of things to criticize. But anyways, let's connect. So you'll notice a cancel button. If I click it, it just goes back to this screen, so it doesn't bypass it.
I'm not sure if it will work that well for you.
So that's also a issue that I've had in the past. So we'll just give it a second and okay, so what I'm going to do is I'm going to try and hotspot through my phone. See if it will work that way instead. Okay, so yeah, so Concordia was blocking it. Now it seems to be making more progress. So we do have this nice progress bar at the top. Seems like it's working. So like, it could have, you notice it took a bit of time. I don't know what your mental model was of how long it would take, but it wasn't instant. But because of that progress bar, you got a sense that it was doing something. It didn't freeze up, it didn't hang. But actually in contrast, because when I clicked it with Concordia, it did hang, right? And I didn't know, like, is it never going to work, right? And one thing that would have been fun, I guess, not for you to watch, but to maybe hang on for a minute and see what it does. My suspicion is that probably it would just never do anything, right? Like, it would have just hung at that stage. So that's actually something that they could they could do to enhance usability. So if Tor is blocked, when you click on connect, it hangs. Okay, so the user doesn't know. Now, it's not going to let you do something dangerous while it's hanging. Okay, so that's good. Okay, so it's still good in terms of like G4, G5. Okay, but in terms of do I know the status, I don't really know the status. I know I asked it to connect, and I know it's seemingly not connected, but I don't know why. You know, eventually it could time out, and then it could give me like some sort of sensible warning, or like it looks like your internet isn't configured to use Tor, or we tried to connect to the Tor network from your connection, and it's obvious that it doesn't work, and so talk to your site administrator. I don't know. There's lots of things like that. So anyway, so that's one small thing that could be better. Okay, so now I'm connected. All right. How do I know that I'm connected? Is my traffic now anonymized?
The traffic just on the web.
Say again, sorry.
Just on the web.
Okay, so there's a question of what is anonymized, but what I'm seeing in the browser window here. So let me type something in. So I type in Montreal Impact. Actually, there's CF Montreal now. Okay. First, you'll notice that it's a little bit slow, right? Why? Because it's going to Europe and US and different places. Okay. Was that anonymous?
Compare the IP addresses.
Yeah, because it never asked us to log in or
Okay.
Maybe if you search the normal browser, shows some CA maybe,
Mm-hmm.
.com. Maybe it's connected to another country, and after that, the browser thought the search engine thought you comes to another browser, maybe.
Okay.
Another country?
So we don't know where the traffic went,
No.
but do we think do you actually think that went over Tor?
DuckDuckGo is the private browser, so private opinion. So I think it's a private.
Okay. Who thinks that went over Tor?
Judging by the speed, yeah.
Okay, put your hand up. Okay, who doesn't think? Okay, who has no opinion? Okay, pick a side. Okay? It's a simple question. You can be wrong. It doesn't matter. Do you think yes? Okay? Do you think no? I still see people who didn't put their hand up. Okay? Pick yes or no. All right? Everyone stand up. Everyone stand up. Stand up. Seriously, stand up. If you think yes, sit down. If you think no, stand up. Okay, good. So you can sit down now. All right. At least I forced everyone to take an opinion. Okay, did that go over Tor or not? I don't know. So how would the user figure it out? So one thing, yeah, go ahead. Okay, so we could go looking in the user interface to try and figure out whether it's on Tor or not. Okay, so what I would expect is some queue. Okay, now the other thing though is that the setup did say, do you want to connect to the network? And I said yes. Then it did something. I assume that connected me to the network as well. Okay, but yeah. So are we sure that we are on Tor? Okay, so I'll note that there was some uncertainty even in the class. So G8, we're not sure the status. Also, we should know that we successfully completed the task. So the core task we're trying to do is to confirm, to basically configure it so that we could be anonymous and then confirm that it was anonymous. So it's sort of a G3 and G8 issue. There's no obvious user queue. So this would be, user queues are sort of G7. G7's like, are you comfortable with the interface? So a queue is like a picture or something. So it could say like, you are now anonymous, right? Somewhere on the Chrome or something, and make it very explicit. So we don't have that, okay? So then we can go and we can dig through the interface. Now, by the way, the answer is yes. So this is over Tor. The mental model of Tor is that if you're in the browser, it's anonymous. So like if it's working and you are connected to a website and you're getting something back, then yes, it is going through Tor. There's no way to force this software to connect to the internet not over Tor. Either it's not going to work, like it will keep asking you to connect. So it's either doesn't work at all or it works, and then when it works, it's anonymous. But it could do better on communicating that to the users. Okay, so we can go look at the lock, and we'll get a bit more information here. So this is the lock interface. Okay, so the first thing is it says this connection is secure. We can even click on that to get more information. Does that mean it's anonymous? What does secure mean in this case? That means it's over Tor. So in this case, it actually just means it's over HTTPS. Okay, so you'll notice that this site is over HTTPS. So what it's doing is it's actually bundling some information about HTTPS with some information of Tor. Is that confusing? I don't know, maybe, right? Maybe they should show you the stuff about Tor separate from the stuff about HTTPS. Or maybe if you understand anything about Tor and HTTPS, you know enough to keep them separate. I don't know. But it's something that you could think about. Right, so it conflates Tor and HTTPS info. Okay, now you do see actual information about Tor. Okay, and it actually has a pretty nice kind of thing here where it tells you, okay, I have 3 nodes. So here's my browser here. First, the entry node is in Finland in Europe. Then I'm going to go to one node in the US. Then I'm going to go to another node in the US. And then I'm going to the actual website DuckDuckGo, which is the default search engine for it. I can change the circuit. So there was a question about like if you can refresh it. So let's just try it. I'm just going to close Safari because I keep flipping to it. So if at any time I want a different circuit, I just click it. So now I'm, and the website refreshed. So now it goes to Finland, then it goes to Sweden, and then it goes to Germany. Say again?
What do they mean by God next to Finland?
Yeah, okay, so that's something that maybe the user would know.
And it remains constant, I guess.
Yeah, so the guard is actually just a fancy name for the first node. So the first node they always call the guard. They used to call it entry guard is so this is called the entry guard. And this sometimes, I don't know if Tor themselves call it, but it's often called the exit node. So it's just terminology for those 2 nodes, and then you have your middle nodes or whatever. Entry guard, in this case, it goes back to like sometimes like Roger Dingledime, who runs the Tor project, personally knows Ian Goldberg at the University of Waterloo, who's running the Tor server for Waterloo, right? And in this case, Waterloo actually asks explicitly to be a middle node, because if you're an exit node, let's say someone goes and does something illicit on the internet, your IP address is showing up. Okay, so it's a liability. And then entry nodes has its own set of problems. But anyways, if there's that personal relationship, then Roger might add you to the entry guard program. And it basically says, I know, like I have some relationship with the person running the server. I trust them. It doesn't mean you should trust them, but they're not just some completely random server on the internet, okay? Whereas your middle node, your exit node could be those random servers, okay? So there's more like kind of human discretion that's involved in choosing the entrance node than all the other nodes on Tor. So anyway, so that's what it shows you. As mentioned, the guard is always the first node. And then they say that the guard might not change. If you want to learn more, you can. And I'm sure it will be a sort of super technical article that let's see what it says. This is normal Tor behavior. The first relay in your circuit is called the entry guard or guard. It's fast and stable. Oh yeah, so that's the other thing is they have some stability requirements and things like that. Anyways, they have a paper that you can read about it. Let's just skip over that. Okay, so anyways, if the user found their way to this box, then they would probably conclude that they are connected to Tor. At least it tries to paint that picture of it being connected. We can just look and see what other stuff there is kind of up here. So we have this standard security level. And, oh, this is interesting. So they have 3 different settings in terms of security level. So this is basically going to have to do with whether you're going to allow JavaScript and other client-side scripting, and then some stuff that could be used for fingerprinting. So JavaScript is probably the most important thing to sort of talk about. So JavaScript is tricky because lots of websites use it. So if Tor decides that they're going to disable JavaScript by default, then a lot of the web's not going to work. On the contrast, JavaScript can ask the IP address of just from the browser and get it. And so Tor doesn't want to enable it because then the website people, they'll say, oh, there's traffic from Tor. No problem. I'll just throw some JavaScript in and figure out what their IP address is. And then it's as if they're not using Tor as well. So what they do is they, I guess they have different sort of graduated levels of it. But I'll note that JavaScript and client-side scripting is dangerous. Now, they may do other provisions as well. So I shouldn't say, I'll say that it could leak IP address, but it maybe they change the browser so like when the request is made, they forge it, or there's different things they could do at the browser level probably to stop this from happening. I'd have to think about whether they can be circumvented or not. But anyways, yeah. So anyways, I'm not saying for sure that if you have JavaScript running that you can always get the IP address, but there is the functionality to ask for it, but that functionality is going to go through the browser. They control the browser, so they'll have some control over it as well. Okay, the other thing I'll just note quickly, I know we're a little overdue for a break, but I just want to wrap this up so we can do something different when we come back. Is what actually, so another dangerous error, I guess, that a user might make. Dangerous errors G5, sorry. Okay, so I have Tor, I opened it up, it's working. Now I want to go down to FTP, or I want to open up my messages or whatever it is. And because Tor is running, they're going to be anonymous too, right?
No.
Why not?
Because it's just web browser.
Okay. So you run Tor, does that mean all traffic is anonymous? And the answer is no, just the browser. So if I want to do my BitTorrent over Tor, if I want to, use BitTorrent, download some files over Tor, can I do it?
No.
Okay, so I can, yeah, so the more complicated answer is I can't, at least with the browser, but Tor offers other software and software you can route different things through it. So, so the user has a client, which is their entire operating system. And in this case, you have the Tor browser. And so everything here is anonymous. But if I open Safari, maybe I have both windows open and then I accidentally start typing in the wrong window. If I use another app. Then these are not anonymous. Not through Tor. Okay, one other just small complication. So whatever, I went to DuckDuckGo. In order to go to DuckDuckGo, I had to get the IP address of DuckDuckGo. How do I do that? Who does DNS? Like, is it handled by the operating system or the browser? So it's actually the operating system. So it's going to get passed down from the browser to the operating system. The operating system is going to go to DNS. Did my DNS query go over Tor or not? If it doesn't, that would be a problem, right?
No, it's not over Tor.
Okay, so it seems like it wouldn't be over Tor, right? And that's a problem because even though people don't know what I'm doing on the websites, they do know which websites I'm going to, right? And so, yeah, the question is this anonymous or not? And so actually the answer is it is anonymous. So they do take care of hooking. So when you install the Tor browser bundle, they hook your DNS requests so that it goes over Tor as well. So they hook in everything for your browser, and then they also hook in DNS. The reason I just brought this up is when I looked at it like 15 years ago, you had to install a separate piece of software to hook all your DNS requests. So it was a real nightmare. You would get Tor, and then you'd have to configure your browser to connect to Tor instead of connecting directly. And then you'd have to configure another thing called Privoxy to hook your DNS requests. And like it was just a nightmare to set up. So now Tor looks like amazing compared to the way it used to look. But yeah.
Sorry, for privacy, did you mention that DNS is preferable if it's handled by the actual operating system or by Tor?
Sorry, is it preferable meaning?
Like which party should handle it?
Oh, so the operating system handles it, period.
Okay.
So the browser doesn't have a choice. But because you're installing software on the computer, you can install more than a browser. So you can install something that also hooks DNS as well. Yeah, yeah.
Can you tell us how technically it hooks the DNS from Tor?
So it would, when it does a DNS request, it will, okay, this is my guess. This is how Privoxy works, so I assume they're doing the same thing. When you start the Tor browser bundle, it would start a server on your computer that's running on localhost or something like that. And then the browser would be configured to send DNS over to local hosts on a certain port. That thing would be listening. And then once it got the request, then it would route it to Tor as opposed to routing it to the operating system. So, yeah. So that's basically what you used to have to do that manually. But now it's happens automatically without you knowing anything about it. At least that's my understanding. Maybe it's the case that DNS is, but I would be shocked if DNS wasn't, because that was like a core principle of how Tor worked, and one of the things that made it complicated. So I'm assuming, but I don't even know how I would confirm it other than sniffing like a packet sniffer. I'm not sure how I would confirm that actually DNS is being routed over Tor. But. Okay, any questions or comments about this? Yeah.
One question.
Yeah.
I thought about it. If we use VPN and also Tor, what
Yeah.
happens?
Nothing. It's just you. Your entrance node. So you can decide whether you want to use it before or after Tor, right?
Yeah.
So you can do either. And so if you use it before Tor, then you'll just go to your VPN, and then your VPN will forward it to Tor. And if you use it after, the same thing. So it will go through Tor first, then it will hit the VPN, and then it will end up at Facebook. So why would you want to use both? The main reason is you want the anonymity, so you use Tor, and you want the geo-hopping, so you use a VPN. So in Tor, you can be like, hey, I need a server in Norway because I want to watch Norwegian television, right? Maybe you can request that. But they don't necessarily have exit nodes in every country, right? But you could use a VPN at the last hop, right? So that, because there's a lot more VPNs than there are Tor exit nodes, right? So you could, and then you have the anonymity. So even if the VPN logs get leaked, then all the VPN knows is that someone on Tor was asking for the information. Yeah.
Thank you.
No worries. Okay, let's take that break. So come back at 7:25. Okay, just two more brief things about Tor. The first thing is it won't stop you from revealing your own identity. So what I mean by that is, let's say you go to Facebook, you're anonymous, it doesn't know who you are, your cookies have been reset, it doesn't recognize your IP address, but then you log in, right? Then now Facebook knows who you are, right? They know you're a Tor user too. So, there's nothing you can do at a browser level to stop that, right? If the user wants to log in, then they're going to log in. Or if they buy something and they fill out their name or address or something like that. So Tor can't do anything at that level. And then Core Task 4 we didn't actually talk about, but it's how do you disable it and return to normal browsing. And so the way it's set up now, once again, these core tasks are sort of old because they're based on how it was working 15 years ago. But 15 years ago, it was harder because you would have to sort of tear down your connection manually. And the way the mental model back then was that you would have one browser. Sometimes you'd be on Tor and sometimes you wouldn't. So it'd be configured to use Tor. And then when you're done with Tor, then you would unconfigure it. And so you had to basically get it back to normal. But now it's like you have two browsers. So you have the Tor browser. If you're in that window, you're on Tor. And you have your Safari or Chrome or whatever. If you're in that window, then you're not on Tor. And so if you want to switch between them, you just switch browser windows. If you're done with Tor, you close it, you're done. Okay? So it's a much simpler mental model now. And so that looks a lot nicer. Okay, any questions about Tor before we move on, or questions about usability? So you will do this for assignment 2. So I'll ask you, I'll give you, probably this is the way it will look at, this is how we've done it in the past. I'll give you a tool that's somehow security related or privacy related, and then I'll ask you to do a walkthrough of it. And usually you could use the same guidelines, but you define your own core tasks. I think that's how we've done it in the past. I don't remember exactly, but anyways. The core part is that you will actually do the walkthrough, and then you'll note things that it does good and things it does bad in terms of all of these guidelines. Okay. So once again, what we do in class, just like the evaluation framework, we did an example in class. It was kind of super high level. Like your assignment, you had to be more detailed and careful. And then there's the academic paper, and that's the gold standard. So same thing with this. We did something in class. It was sort of sketchy. With the assignments, you'll have to be a little more precise as you go through a methodological. And then if you want to read what an academic paper looks like, you can read the Tor paper, or there's lots of cognitive walkthroughs of all sorts of different things to see what that looks like. So for the assignment, you might want to look through the cognitive walkthrough just to get a sense of kind of what it looks like when it's written up. But anyways, you at least are familiar with what you have to do. Okay. Final chance for any questions or comments? Okay, so now we'll switch gears again completely. And this actually will be the last topic, maybe second last, depending on how fast we go through it. But I want to talk a bit about procedures or policies. So a procedure or policy is another aspect of security that often is ignored, right? So what I try and do in this class actually is I try to, like, I'm not going to tell you about security evaluation of crypto because you're going to take a crypto course. I'm not going to tell you about network security because you'll take a network security course or whatever. So what I try to do in this course is pick up all the like sort of stuff that's left behind from the other courses. And so procedures is something that usually involves humans. Okay, there are security consequences to it. And if you don't get it right, if you don't get the procedure right, then you'll fail in terms of your security goals. Okay, so to illustrate procedures, we'll look at two things. The first example will be something that we all know, probably we've all been through it before. It's just to get us thinking like about it. I'm going to talk about airport security. And then more technically, I will talk about something that you will see in other courses. But when we talk about it in this course, it'll be a little different because we're going to look at it as a procedure or a policy. Okay, we're not really thinking about the attacks and how you defend against them and stuff like that. We're looking at it as someone had to make some decisions about how, in this case, how a browser is going to run, and there were consequences to those decisions, right? And it resulted in weird behaviors and things like that. So we're going to look at something called the same origin policy. And that's something that's implemented by your browser. But it was the designers of the browser that decided. So your browser doesn't know what it should do. So someone, at Netscape in the 90s had to say, okay, it should do this, right? And so same origin is going to cover things like cookies. So how are cookies set, who's allowed to read them, when do they get sent back, all that kind of stuff, and scripting as well. So yeah, if you have, so same origin policy is technically about scripting, but it's based on procedures that were developed for cookies, so they have a lot in common. So if you have a website and there's scripting that's being pulled in from different sources, like how do you run it? Or if you have a website that weaves content together, it has like a frame that goes to somewhere else. Like, can that frame see the stuff in the other frames? How do you want to manage that? And so a lot of security vulnerabilities, like things you've heard of, like cross-site scripting, cross-site request forgery, and things like that, it all comes down to the same origin policy. So if that policy were different, then there's no policy that wouldn't have a certain set of attacks, but the attacks that we see are specific to how that policy was decided. So that will be more of a concrete technical example. But before we do that, let's just talk about airport security just as something that we're all familiar with. And there's a lot to learn about how to set up a procedure and a policy from just thinking through a simple example like this. Okay, so when you think about airports, everyone's flown, I assume, and you know that there's a lot of security involved, right? There's things like identifications. You have boarding passes, you have tickets, you have your passport. You're showing it to certain people. There's different checks. There's the whole like X-rays and metal detectors and things like that. So there's that whole aspect. There's consequences. So there's certain things that you could get in trouble for from law enforcement. There's things like no-fly lists. So some people are allowed to fly, some people aren't. So there is a lot of security that's baked into the airport. It's not just a simple show up at the airport and go on your plane. Okay. And the thing that makes airport security complicated that we'll see is that there's actually different parties that are involved in it. So it's not. You might like reduce it to like you and the government, right? So the government has something. There's like you, the traveler, and then all the security stuff is just the government, right? But it's not just the government. First off, sometimes it's commercial, like the airlines that are involved, and the government itself is divided into different agencies. So some governments, like law enforcement, police, they're interested in a certain set of things. Some people are border services. They're interested in a different set of things. Some of them are like CTTSA or TSA is probably the more common one. They're the people like the metal detector people. So they're different. So the people that you show your passport to cross the border is different from the person that's scanning your bag, and that's different from the police kind of thing. And so depending on what the issue is, you could get involved with different ones. Okay. So anyway, so it's sort of a complicated kind of song and dance. So let's just go through the procedure first, and then I'll just make some notes about things that happen that maybe you're not always aware of. So the first thing starts before you even show up at the airline. Security starts actually when you purchase your ticket. Okay, so the thing about buying a ticket is right from the purchase, it's tied to your identity. Okay, can you give your ticket to someone else?
No.
Okay, you can you sell it to someone else? You can't. Okay, so it's non-transferable. Now there's always like plots like in movies and things, and I don't know to what extent it's true, where there'll be like actually, I was just watching the new season of Curb Your Enthusiasm, and this was an exact plot point of like whether someone with the same name could travel. Like if you buy a ticket for one person, could you find someone else that has the exact same name and have them travel? And I don't know the concrete answer. I'm not an expert on this, but I assume the answer is no. I think it's not just tied to your name. I think that's just like something invented in movies. I think it's actually tied to your passport number as well. But anyways, generally when you purchase a ticket, we'll say it's tied to your name. And I'll put passport in with a question mark. I don't know, has anyone bought a ticket recently either having to reveal their passport number or not having revealed, or does anyone remember? You do? Yeah. So that's my feeling too. But usually you tell Expedia or whatever what your passport number is and whether they forward that or not. Okay. So yeah. So you sort of have maybe you have Expedia or someone that sits in between. Maybe you go direct to the airline. So you have Air Canada. So you're going to say, I want a ticket. And you'll pick it out on Expedia. And then when you click OK, then you have your ticket right away, right? Careful. Okay, so you pay, so that's fine. So you go on Expedia, it saved my credit card number. I find the flight, it's on Air Canada, and I click confirm, and then the ticket's all confirmed. It's not. Okay, so I'll get a message that says, okay, we have to get Air Canada to confirm this, right? You should get a confirmation email within 24 hours or whatever it is. Okay, so why is it not instantly confirmed? So it's paid for. Expedia takes the money. Air Canada doesn't care. Why is Air Canada confirming it? Are they making sure they have room on the plane? Like they didn't overbook? So that could be the case, right? But now it's all digitized and they have real-time systems and things like that. So I don't think that Air Canada is worried about that. Okay, so what Air Canada is doing is they're actually checking with the government to see whether you're on a no-fly list. Okay, and then they're going to get confirmation. And so if you're on a no-fly list, you'll get stopped actually at the ticket purchase stage, usually. Sometimes you hear the stories of like the people that showed up at the airport and then they were turned away. But normally it's supposed to happen that you would actually be prevented from even buying the ticket. So Air Canada is going to do a check with the government. Air Canada doesn't have the list, okay? So like the government doesn't just give the list to Air Canada and say, okay, you check yourself, okay? They have to go to the government and check it. It's sort of like top secret information. And so then the government will say yes or no. and then 20. This whole process could take a day or whatever. I don't know how fast it is, but anyway, sometime later, assuming you're not on the list, then you'll get a confirmation. Now, no-fly lists don't seem to incorporate passport numbers. They seem to be based on name, or maybe they're being super conservative so that if someone with the same name shows up but they have a different passport number, then they will still not allow them. But every now and then you hear of people that were flagged. Sometimes it's like babies, like someone that's like 1 year old, and they just presumably have the same name as someone that's on the no-fly list. Because they're 1 year old, you assume that they probably haven't done anything that bad in their life that would warrant them not to fly. And then there's the whole process of like, what can you do, right? Like, can you go and get it overturned or something like that? And then it's a big black box because it's covered in national security. So like, do you sue someone? Who do you sue? Like, what division of the government? Blah, 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 blah. So anyways. Okay, so yeah, question.
Is that international or like based on each country? Because like if you book with another airline.
Yeah. Yeah, so once again, no one knows the details, but almost assuredly it's national. So Canada has its own list that's different than any other country. That's maintained by Canada at the federal level. But they definitely are getting names from the US and the UK and other like allies and things like that. So they're definitely sharing that information amongst them. And so most of the list is probably common, but it is Canada's list, and there's no guarantee that it's exactly the same as anyone else's list. Okay, so, all right, so let's assume that we get the ticket. So that's great. So now we're ready to go to the airport. All right, so you've all flown, so what do? You've walked in the doors of the airport. Where do you go first? Okay, so there's going to be a variation of procedures depending on whether you checked in online first or you checked online. You didn't check in online, whatever. Okay, let's say you didn't do any checks at all. What's the most complicated thing that you might have to do? Okay, so you're going to check in. So who's that with? Is it with the government, with law enforcement, with the airline? So the person you're talking to is an employee of Air Canada. Okay, all right. So whatever, you could skip it as well. Let me just write skip over. Okay, so your other options are you could use your phone ahead of time or the internet just in general. Let me write that as a website. The other thing you could use is a kiosk. Kiosks are those like computer terminals that are sitting there. And so you don't have to talk to someone specifically. What do these things want to know? Whether you're doing it online or you're doing it on the website, what do they want to see from you? In terms of identity? Okay. So they want to see your passport. So I'll write it this way. So the input is your passport. Are they checking whether the photo is actually the person that shows up?
Well, I think that these days is different because before that, yes, just they look the photo and sometimes they change the photo, but these days I think it's different.
Okay. Possibly. What is?
They tell you to remove your mask.
Okay. So if you go to an in-person, they might want to see your face. If you use a kiosk, does it know what your face looks like? Is there on the kiosks that give you your boarding pass? So I know when you cross the border, there's a picture.
If you need a visa, they force you into a person to check.
Okay. So there could be a separate procedure, yeah, if you need a visa or something like that. What if you're using your smartphone? Right? If you use your smartphone, can you just skip this entire step? Okay, so you can skip it. You don't have to talk to anyone. You can just walk. Well, we'll talk about that in a sec. Okay, so it's basically they're going to look at your passport, but no picture. Not necessarily. There's not necessarily going to be a no picture check. Okay, and what's the result? Why are you doing this? Okay, so you want your boarding pass. So that's the output. And so that's basically what you're going to carry through this whole airport procedure from now on, is you kind of have like two things, like the two things that you always have in your hand, right? You have your passport, you have a picture, which is on your passport. I guess you have you, like what your face looks like, and then you have your boarding pass. So if I want to do like a full check, I'm going to check, are you the same person as your picture? Yes, that's your passport. Now I know your name. Is the name the same on the boarding pass? The boarding pass is from Air Canada, whatever. So that would be like a way to tie all of that stuff together, okay? But as we'll see, most people almost no one looks at every aspect, right? Everyone's just interested in like some piece of it, like the piece that involves themselves. But anyways. Okay, what if you have bags? What happens? Okay, so that's another thing that you can do here. So you can register with the Air Canada person. You can do your baggage check. Actually, okay, I'm going to keep it. I'm just going to set it off to the side. I'm going to elevate that to another point. So that'll be point number 3. Okay, I just wanted to quickly say something about your boarding pass. Okay, when you look at a boarding pass, okay, is it printed on like special paper or something like that? Like, is it like your passport has some sort of physical security, right? It has holograms and things like that. So if you look at a passport, you know that came from the government of Canada. It wasn't like someone printed it off in their basement, right? What about your boarding pass? Okay, so it doesn't, first off, it's not printed on any special paper. It doesn't even need to be printed. It could be something that's on your phone or something like that. Okay, so there's no physical security, like in terms of the paper holograms. So this is something that changed maybe slightly. Like before all these kiosks and things like that, you would get a boarding pass that kind of looked like a ticket. I'm not saying it's hard to forge, right? Like but at least most people in their homes wouldn't have something where they could just print it off and make it look like a boarding pass. Okay, and then there's usually a barcode or something like that. Okay, so there's some sort of barcode. So that's basically going to replicate in digital format. So digitization of just the same stuff that's printed on the ticket, right? So you have your name, your seat number, whatever, your gate, whatever, all that stuff, it's on it, okay? Now let's say you want to sit in first class. Okay, so you go in the barcode and you see where it says your seat and you just change your seat. Can you do that? Okay, so let's assume the answer is no. I see some people shaking their heads. What stops you? Why can't you do it? Is it because you can't read a barcode?
What are you trying to do? Changing?
You want to change your seat. So whatever. So you're going to have a problem because when you get on the plane, there's going to be someone sitting in your seat. But let's we'll punt that problem down the road, and just say that you look at your boarding pass and you're sitting in 4A and you want to sit in 1B. So you just go in, right? You look at the barcode and you just, like, say it's on your phone, you just go in and you replace 4A with 1B. Now when someone scans it says 1B instead. Okay, so we think no. So why? What stops you? What could stop you? Forget about like what actually happens.
They have a database they assign to another people.
Okay, so it could be that the QR code is just a pointer to a database entry.
Yeah.
Okay, so let's just enumerate the options. Okay, so actually digitization of information is its own option. Okay, so it's like the barcode has your name in it. Okay, so that could be option 1. Option 2 is it could just be a pointer to a number, right? And then you go and you look it up in a database, and then you get the name. My name's in the database. It's not actually on that QR code. Okay. So this is kind of like similar to that vaccine passport stuff that you looked at. There's different options. So it could be a database pointer. Okay, let's just pretend it's the second thing and not the first thing. Does this work if you don't have an internet connection? No, it doesn't, right? Okay, so probably not. I don't know for sure. I know what used to be the case, so I don't know what's currently the case. But I'm guessing that this isn't. Also, if you look at the size of the barcode, it's pretty big. Okay, it's not just a unique number. Okay, so I'm pretty sure. I can't be 100% sure because I don't make these things, but I'm pretty sure that it's the first one. Okay, but this is an option. It is a valid option. It's probably more secure to do it this way. But yeah. Okay, let's say you want to actually put the information on it. Can you still stop someone from changing it?
No, we can't.
Okay, we can't. Anyone think we can? What about like certificates? Like, could we sign it or something? Okay, so we could use some crypto. So that's another option. So I'll just put signature. So we could have a digital signature. All right, so do they use digital signatures or not? I'm going to put it as unknown today. But in the past, the answer was no, they didn't. Okay, so I can only tell you about what security people looked at. And some of these stories are kind of old now, like decades old. So like I have no idea. I would hope that they put digital signatures on this stuff. But as far as I know for sure, we don't know whether it's even signed. Okay, so as of a few years ago, if you wanted to change your seat number or something like that, you could do it. If you want to change your name on it, you could do it. And a more practical thing, the problem is if you change your name, then it's not going to match your passport. So that's a whole thing. If you change your seat number, you're going to end up in the same seat as someone else. So now there's 2 people that have the same seat number. And then, I don't know, they'll probably check with Air Canada. They'll look up your name and see what seat you're supposed to be in. So it's probably not going to actually get you very far. Another thing that's like very minor, but that people would do is in the US, they have a program called TSA Fast Check. I may have the name wrong, but it's something that's printed on your boarding pass. And if you have it, you can go through a security line that's faster. It's kind of like in Canada, we have this Nexus program. So like when you go to security checks, there's the ones for regular people. And then if you have this Nexus card, there's another one. It's kind of like a VIP one. And it's usually a shorter line. Other than that, it's no different. Like they check the same thing. It's the same equipment and things like that. So, and in that case, the boarding person, they're just looking at your boarding pass. Okay, they don't have a database. They don't have an internet connection. They're not the airline. They don't know what ticket you have. They don't know what you're flying. All they're looking at is this document that you have or this barcode. They scan it. The barcode says that you're, approved for TSA Fastline or whatever. You're approved. Okay, so that's it. So because not all the people talk to all the other people and everyone shares data and things like that, then things like this are possible. Okay, so I'll make a note of that when we get to that. stage. But for now, we'll just note that yeah, your boarding pass isn't anything special. It's just a barcode that has a bunch of information that may be changeable, may not be changeable. All right, now you're going to drop your bags off. So who do you give your bags to? All right, so the airline's going to start with your bags. Then they throw them on some sort of conveyor belt. And can you just directly go and put your bags on the conveyor belt? Do you have to talk to someone from the airline? So actually the answer now is you can. You need to at least get the sticker to put on it. So you can get that from a kiosk. So you can't do it from your phone because then your bags won't have any tags on it. But you can go to a kiosk. So you don't actually have to talk to someone. But you basically, the output will be some sort of sticker or tag that you put on your bags, and then you can drop your bag in the belt. Okay, then what happens to it? So we know at the very end it ends up on the plane, right? Does anyone look at your bag in between? What do you, like, you don't have to know the answer, what would you guess? Yeah, of course. Okay. So we don't know for sure, but there's almost certainly, let me write that. Security screening. So what does that look like? It looks like X-ray machines. It could be like dogs sniffing for. So what are they looking for? Let's say it's a dog. Okay. So there's two things, and they're actually different. One is it's looking for a bomb, and the other is it's looking for drugs. Okay. They're different because basically different. Well, first off, they're both crimes. Okay. So they're both going to get you in trouble. Okay, but they're going to get you in trouble with different people. So the bomb is, they're sniffing for bombs because they don't want you to blow up the plane. Okay. And that's like the TSA or the TSA in Canada. Okay, that's their jurisdiction. So their one job is basically to make sure that you don't get a bomb or a weapon or something like that on the plane. They don't care about drugs. Okay. Now, if it's obvious that you have drugs on them and they detect it, obviously they're going to report it. But that's not their job. They're not there to try and make sure that you don't have drugs. Law enforcement is there to try and make sure you don't have drugs. And if you're going to cross a border, then the border agents, that's also their concern. Okay? So the border agents care about drugs. TSA care about bombs and weapons. And if you're flying domestically, meaning you don't talk to a border agent, then law enforcement is concerned about drugs, essentially. Okay? So it's there's much more of a concentrated effort on keeping weapons and bombs off of planes than there are to keeping drugs off of planes, but there could be checking for both. So this probably it's both. It's a sort of combined effort from CT, TSA, border services, and then just law enforcement in general. What if you lock your bag? Let's say they detect it and they want to open it up. Okay. So there's these actual like. First off, they're authorized to break into it. So any bag they want to search, they can search, and so they'll break the lock, cut open your bag, whatever the case is. Then people were getting annoyed because they were locking their bag not because they didn't want law enforcement searching through their bag. They accepted that, but they were just concerned that like their bag's lying around somewhere and like some employee of the airline gets nosy, or when it comes off the plane at the end and you're at your destination, that someone else grabs the bag by mistake and then they open it, or they try and steal it or stuff out of it, or I don't know. You're walking through the airport, you get coffee, you're not really watching your bag closely. So what people want is they want to lock for like that purpose. And so then TSA in the US had this brilliant idea where they had special locks where you have a personal key. So If 5 people have these special locks, none of their keys will open each other's locks. Okay, so it is a personal key. But then there's a master key that TSA has. And it opens all locks. So if they want to go through your bag, it's fine, but they won't break your lock. When they're done, they'll lock it again, and now you still have a lock. Okay? Now, here's the big problem with master keys, and this doesn't just apply to locks in airports, it applies to cryptography, whatever. How many TSA agents, I know that's an American thing, but let's assume the CTSA also have the master key. You know, how many people are there in the world that work at TSA or CTSA, right? Probably thousands, tens of thousands maybe. So that's a lot of master keys that are around there. How many people does it take for that master key to leak? How many of them do you need to compromise? One. Okay, so it takes one person somewhere for one period of time to compromise a key. What does that mean? Like, you pay them, you could bribe them for the key, you steal it from them. How would you get a key from a TSA agent if you wanted? If I knew that you worked for the TSA and you had this master key, what do I have to do to you to get it? So I can steal it for sure, right? First off, I just need access for a second, right? I can take a picture, okay? So it's not even, if you're walking around and you have it like a keychain on your like belt and your key is sitting there, if I can get a picture of it, I can 3D print the exact key, okay? So it took very little time before it leaked. So the master key basically leaked. It's online. If you want it, there's lots of people that will sell it to you, or you can 3D print it yourself. And it will open every single TSA lock in the world because they were all designed on purpose to all be opened with this one key. All right. So that kind of thing almost never works, right? And so sometimes you hear about government, like with encryption, they want to, it's called key escrow. So like law enforcement will have a special key that will unlock all communications and things like that. As soon as you do that, it's going to leak eventually. Okay. DVDs, or like, you might not remember DVDs, but anyways, like you used to watch videos on like these discs, right, that you put in a machine, and it had encryption on it, right? So the idea was that you couldn't pirate. If I got a DVD from the rental store, I couldn't make a copy of it, right? But all the DVDs have to be printed, and they all have to have the same key, and that key has to be in every single DVD player in the world because it needs to decrypt it in order to show it on your TV. And that includes software that's in your computer. So somebody, like, that key is baked in, right? It's baked into all software, all DVD players. So it takes one person somewhere in the world once to reverse engineer a DVD player or decompile the software, get that master key out, and then you can watch any DVD movies. Now, eventually, like with Blu-ray and things like that, they had kind of like a evolving key schedule. So like if a key got leaked, they could, like, future DVDs wouldn't use that key. They could like kind of revoke it. But anyways, the whole thing got too complicated to manage that they eventually even though the technology was there and in theory they could do all this key revocation, they ended up not doing it because it was too much of a nightmare to maintain. So anyways. Okay, the other thing I'll note about your bags, so it's the middle of the flight. You want to go grab something from your bag, can you? Your checked bag, not your carry-on. Why not? So it's not allowed, so that's true. Could the pilot go and get something if they wanted to? Okay, so usually on an airplane, it's like it's physically separated. So it's like you can't even get into the cargo area. It's like physically isolated from the rest of the plane as well. Just because we're drawing pictures, I'll draw a picture here. Try and draw an airplane. I don't know. So the inspection sort of CTTSA, and in Canada, this Canada Border Services would be the other people, and then it could also be the law enforcement. So I'll put law enforcement agency. So it could be the RCMP if it's federal. It could be Quebec Police, SDQ, and it could be Montreal Police if it's at Trudeau. I don't know which level of law enforcement looks at it, but anyways. Okay, great. So now we're done with our bags. We have got our border pass, and if we did it all on our phone and we're not checking bags the way I like to travel, then we just walk into the airport. We can skip that whole like chaos at the front. Where do we go next?
Airport security.
Okay, so we want to go to airport security. So what does that look like? Just walk me through. Who do you talk to? What do you... Say it louder.
You talk to someone first and you show them that you do indeed have a ticket.
Okay, so someone first meaning first
Right.
Before what?
Before actually like throwing your bags.
Okay. So usually there's a lineup. There's the machines that are over there, and there's someone that's standing right at the start of the lineup, right? And they want to see stuff before they even let you line up. Okay, so we call that pre-screening. Okay, so 3 questions. Who is it? What do they want to see from you? And then what's the result of after you're done with them? Okay, who is it? So is that someone that works at Air Canada?
No,
Why not?
because they handle all of the
Okay, all airlines are going through the same line. Not necessarily, they might have multiple gates, but Trudeau only has 2 gates, right? There's domestic, international, and US. So yeah, so they're not for the airline. So who are they with? Do they have a gun?
Yes.
They're airport security, so they work for the airport itself.
Okay, generally they don't have a gun. I'd have to double check that, but I'm pretty sure this person does. There are lots of people with guns that you'll talk to. This person usually doesn't.
they have a scanner.
Yeah, they have a scanner. They're going to scan something. Okay, so they work for TSA. So they're with the transport security. So CTTSA. They're the same people that will eventually, make you put your bag through the X-rays and things like that. Okay, so what do they do? What do they want to see from you?
Boarding pass.
Okay, they want to see your boarding pass. Do they want to see your passport?
No.
No, I don't think so. Before.
Exactly. So they don't care about your passport, so they don't know who you are other than what's written on your boarding pass. Could what's written on your boarding pass not be your real name? Maybe. Right? So anyway, so it's not an identity check. Okay? So they're just checking your boarding pass. Why?
Well,
Is there a security reason? Is it just to make sure you're in the right place? Guess?
maybe we changed the boarding pass to different.
Okay, but they're not checking your passport, so
Maybe they have
Check
some.
at least
To make sure you're in the right flight.
say again.
To make sure you're in the right flight.
Okay. So there is a convenience element to it. So let's talk about that first.
Right gate.
All right. So they want to make sure, you're at the right gate, or like the right security entrance for the gate that you have to go to. The second thing they do is they actually are going to mark the fact that you're in the airport. So sometimes they want to know, like say the flight's about to leave and you're missing. They might want to know, okay, did this person show up? Oh, they showed up. Where did they get through security? Did they come out the other end of security? Are they in the security line somewhere? So it's used to track movement through the airport. tied to that is they'll timestamp you too, so they sort of know when did you enter security. Were you 30 minutes before your flight was supposed to leave like you're supposed to, or whatever the case may be. That may translate into a decision of whether they hold the flight for you or if they don't. Okay. Is there any security to it? So the answer is yes. They also are a screening agent. I can't tell you, like, all this stuff is like secret, right? So we only know like things that have happened in the past that have got leaked. So everything I tell you in this lecture may not be true anymore, but we know that as recently as a few years ago, they deployed a program called Spot. And the idea is that they were looking for behavioral indicators that there might be problems with you. Okay, so they're not just standing there scanning your boarding pass. They've actually gone through training in this program, and they're looking for certain signs. And if they see enough of the signs, then they're going to do something like they'll talk to law enforcement or something like that. So the Spot program itself, I'll give you a taste of what it looks like, and then we won't spend too much time on it. So we only know about this program because it leaked. So someone that worked at TSA leaked it. And the reason they leaked it, and there was a lot of press about it, is it was controversial. And the reason it was controversial is people felt like it didn't actually, well, first off, empirically, it didn't seem to actually do much. And then people felt that there were sort of like racial undertones and things like that as well to it. So just to give you a sense of what it looks like. So it's a point-based system. So they're looking for whether you are stressed, whether you exhibit signs of fear, whether it looks like you're lying, deceiving. And then basically they're going to give you a bunch of points. And if you get enough of them, so for example, you can get a couple. So if you get between 0 and 3 points, then you're allowed to proceed. If you get 4 or 5 points, then they're going to give you to secondary screening. So that's going to be a more detailed screening process. And if you score 6 or more, they're going to notify law enforcement right away. And you can lose points as well. So if you're traveling as a member of a family, then they'll take 2 points off. If you're married or you look like you're married, then they'll take 2 points off. If you're a male that's over 55 years old, sorry, a female over 55 or a male that's over 65 years, you're also considered low risk. And so they'll deduct 1 point. So always travel with a family or a partner. And then these are some of the things that you should be very careful about. And I hope not to stress you out so that you're like really worried about this next time. Sorry, this PDF reader is not that great.
So something like this is still in use?
So we don't know. So that's the thing. But yeah. So stress. So this also kind of ties to social engineering because it's sort of looking at psychological elements. But so if you're panting, if your face is flushed, things like that. If it looks like you shaved a beard recently, so that was one of the things that was sort of criticized because different people have beards for religious reasons. Repetitive touching of your face. If you smell bad, so always put deodorant on. Yeah, so like if you have a cold penetrating stare, that can get you in trouble, or if you have widely open staring eyes. Deception, if you're wearing a fake mustache, then they won't like it. If it looks like you're signaling to other people that are in line, then that will also trigger it. Okay, whoops. Then there's other things. There's another set of point stuff here as well. So like different things that you might carry. So this might be later at screening when you open your bags and they're looking for like through it and things like that. But if you have GPSs, some sort of military stuff, blueprints, those kinds of things beyond like liquid and gels, we all know. If you have a whole bunch of prepaid cards and cell phones, rope, wire, loose batteries. Those are things. And then the signs of deception are similar. Here, if you have these kinds of things, then you need less points basically to get referred to law enforcement. But things like gazing down, so if you don't make eye contact, if you clear your throat excessively, and yeah. And then these are the really bad things that automatically you get. Like if you just have one of these things, they'll notify law enforcement. And so a lot of these are like pretty obvious. So if you look like a suicide bomber, if you're interfering, if you are deceiving, if you actually have a weapon on you and they find you, if you have a large amount of money that's like over $10,000, I don't know what large amount is, but something like that. If you refuse to go through screening, anyways, then they'll refer you to law enforcement right away. So anyways, take some time in the coming week, go through the list, and then I'll talk to you next week about whether this was a successful program or not a successful program.